Hello, chemistry student. Hope you are having a good day so far. Let's begin 13.3. So just reminder, at STP, that means 0 degrees Celsius or 273 Kelvin and 1 atmospheric pressure or 101.3 kPa, 760 millimeter mercury of pressure. All gases are roughly 22.4 liter for 1 mole. So with that, let's use that fact to do this calculation. So 105 liter of oxygen at STP was used up during a reaction with ethylene gas. What is the volume of carbon dioxide produced? Okay, so 105.0 liter of oxygen. We're going to convert that from liter of oxygen into mole of oxygen first to use the mole ratio. So this is connecting to material we learned last trimester. And almost every bracket is going to have mole one time. So if I don't see mole yet, I know that's going to be mole. And since the bottom is going to be the same as the beginning, I know that's liter of oxygen. And every bracket I only can have one change. So since I'm already changing from liter to mole, I have to keep this as O2. The number in front of mole whenever is opposite to a different unit is 1. And the number opposite to mole when it's in front of liter is 22.4. The information from the previous slide. I cancel that out. And now I have mole of oxygen. I can use the mole ratio of oxygen to carbon dioxide to figure out how many mole of carbon dioxide I need. So here I go, mole of O2 to mole of carbon dioxide. That is allowed because both of the unit are mole, so I'm only doing one change when I'm changing from O2 to CO2. The number in front of O2 again is a 3. And the number in front of CO2 again is a 2. So I cross that out. Now I have mole of CO2, but it doesn't want mole. It wants the volume of carbon dioxide. So let's pretend I continue down here with the third bracket. So what would go in the bottom would be mole of CO2 because I want to get rid of that since my goal is volume. And the unit for volume internationally is liter. And the chemical is carbon dioxide, which is CO2. And once again, the number in front of mole is 1 when it's opposite to liter. And the number in front of liter is going to be 22.4. So let's cancel that out. The only unit I have left is liter of CO2, which is what I want. And now I notice this is 22.4 on top. This is 22.4 on the bottom. 1 we don't care about. So all I have to do is take 105 times 2 and then divide by 3. So 105 times 2 divided by 3 is equal to what? And based on my calculator, the answer is 70 liter of CO2. We did right here on the previous slide. What we did right here. Okay. Just one bracket like that. Let's go on to the next question. Here I have a blank page. I just want you to look at this to remember that we use the number in the front when we're converting from one chemical to another, and that's called the mole ratio. And so let's go forward. But you have to determine which one is on top. Okay. So if I have 15.85 liter of hydrogen gas, so I know this is one of the substance I'm interested in, reacts completely with excess nitrogen, so that one's not very important since it has no number. At a pressure of 4 atm and a temperature of 308 Kelvin, what is the mole of ammonia produced? Okay, so let's change the liter into mole of hydrogen first, and then once I know the mole of hydrogen, I can use the mole ratio to convert it to ammonia. Okay, so I know I'm given liter, I'm given pressure, I'm given temperature, so I know the equation most appropriate is PV equal N or T. Okay, P in this case is not what I'm wanting to find because I'm already given P. I'm given T already. I'm given volume. So R is a constant, which we know is 0.0821 or 62.4. So what would I do? I'm looking for N then. So I'm going to rearrange this equation to get N. So I'll divide both sides by RT. That cancels it out, so I get N by itself. But what if I do on one side, I do onto the other side. So now I know that N is PV over RT. So N is equal to pressure, 4.008 TM, times V, which is 15.85 liter, divided by R. Since this is in ATM, I'm going to use the R value that matches that, which is 0.0821 liter ATM over mole Kelvin. And T in this case is already in Kelvin, so I don't have to convert it. It's 308 Kelvin. So let's see if all the unit cancel out and it makes sense. So I cancel out ATM with ATM, liter with liter, okay, Kelvin with Kelvin, and the only unit I have left is mole, which makes sense because I'm looking for N, which represent mole. So I grab my calculator, I go 4.0 times 15.85 equal, divided by 0.0821 equal, divided by 308 equal, and I get roughly 2.507 mole. And you don't need to keep more than 3 decimal places for this class. Okay, that gives me the mole of what? So I started out with hydrogen, so that gives me mole of H2, but that's not the final answer I'm trying to find. I'm trying to find the mole of ammonia. Okay, so now with that, I'll do my conversion bracket. So I start out with 2.507 mole of H2. So I put mole of H2 in the bottom. And since I'm looking for mole of ammonia, I can go to mole of ammonia. And that is one change, so that is allowed. The number in front of H2 is a 3. And the number in front of ammonia is a 2. Cancel that out. So now I have mole of ammonia, which is exactly what I'm trying to find. So this problem is usually divided into 2 smaller problems, but here I combine it into one just to respect your time. Okay, so 2.507 times 2 divided by 3, and you get 1.67133. Let's just make it 1.671. Very similar to which one's in the bottom. Let the similar to my example right here in the black part. At least you don't have to do the red part, you just have to do the black part. So with that, let's look at some of the questions that you have to do. So first you have to balance the equation. So you will have to fill in number in some of this spot, not all of them, because some of them might be 1, and you can leave it blank or you can put a 1 in. Once you have that, let's see what you're given. You're given mole of oxygen, and you're trying to convert it to how many liter of carbon dioxide. So let me just give you a hint, okay? You're gonna go mole of O2 and convert that into mole of CO2 first using stoichiometry or mole ratio. That's one bracket. So every arrow represents a bracket, okay? Then you're going to take mole of CO2 and you're going to convert it to liter of CO2. And that'll be a second bracket right there. So every arrow represents a bracket. So mole of O2 to mole of CO2 using the mole ratio, the mole to mole bracket. And then you take that and you add a second bracket where you go from mole of CO2 to liter of CO2 using molar volume at STP, which is 22.4 liter per mole. So 22.4 liter over 1 mole. Okay, so 2 bracket conversion there. The answer in liter of CO2, guide you. So that is, assume the reaction takes place at STP, because we already said it was STP in number 1. Take the answer from number 1 and convert it to mole of CO2. We know what we're starting out with, right? We can convert it to mole of CO2. And that's one bracket because CO2 is staying the same. We're only converting from liter to mole. So that's just a simple one bracket where you go from liter to mole. We're going to have some. So now the last question is use the answer from number 2. So mole of CO2, right? use the answer from number 2 and determine the pressure in millimeter mercury. So we're going to have to use the all value for mmHg, okay? So not the 0.0821, but pick the one that has mmHg in it using your note from a couple days ago. You do have to look up stuff sometimes. So now we have mole of CO2, and we're trying to figure out, what is the pressure? So I have mole, right? This is N. I have liter, which is volume. I have temperature, which is T. So what equation has NT, and I already have all value in my note is going to be PV equal N all T. Sorry, that's an ugly N. Okay, and what you're trying to find, basically similar to the one I did, you're trying to find P. Okay, but you already have N, you have V, you have T, so you're looking for P. And of course, you already have all from your notes. And with that, good luck.